Lesson on aircraft performance. How do pilots know that stuff? Like we talk about, you have to know how long it's going to take you to land, how long it's going to take you to take off, fuel burn. We talk about. I throw these things out in class all the time, and at some point, hopefully, you're like, how does he know this stuff? Well, the truth is, I know it one of two ways. Number one, I've just flown airplanes a lot and I've just memorized certain numbers or recognized patterns while I'm flying. But number two, quite honestly, the real answer is I use these things called performance charts to figure out how in the world my aircraft is going to perform. And I don't guess at it. I use the charts, and the charts are usually made by the manufacturer, and so that you kind of have a solid background from an engineer that can help you determine all these important calculations, some of which are required by law, and some of which just things you need to know, point blank. So, anyways, let's get to it. This is just gonna be a lot of vocabulary. This packet's just a lot of vocabulary words because we're gonna be doing a lot of hands-on stuff with these charts in class. So let's get to it here. So imagine the following: you're flying a small single-engine aircraft. You and another passenger will be in the front seat, and two small kids will be in the back, and they each weigh 100 pounds each. Also, there's about 50 pounds of baggage being brought. Is it safe to take off? Think about aerodynamics. We talked about CG, right? It's like, well, is the CG in the right place so we can safely take off? How would you calculate that? How would you calculate that? So we're going to go over kind of how to do those things in class using different charts, and we're going to talk about weight and balance. So let's get some vocabulary out of the way for this lesson so we're ready to go. First thing, weight and balance. This is the process of calculating the distribution of weight in an aircraft to ensure it remains within its specified limits for safe and efficient flight. Weight. This is the force exerted by an aircraft due to the gravitational attraction of the Earth. It includes the weight of the aircraft structure, fuel, passengers, cargo, or any other items on board. Arm. The horizontal distance from a reference point to the location of the item's weight, usually used in weight and balance competitions. So like if you imagine like a lever, you've got like a fulcrum and then you have like a lever going across it, okay? So the distance from the fulcrum to the edge of the lever, that's the arm. And the longer a lever is, the more force it can exert with the same amount of effort. So a short arm, you could move a big stone, but if you had a really long arm or really long lever, you could move the same big stone using the same force. So we use the term arm in flying. And I'll explain more about that in class. Moment, this is the product of the weight in the arm. So product means the answer to a multiplication problem. It's used in weight and balance calculations, and it represents the rotational force around a reference point, usually the center of gravity in an aircraft. And we keep talking about the center of gravity, so here it is. The point of an aircraft where its total weight is considered to be concentrated. Basically, if you think about all those axes, the lateral, the longitudinal, the vertical axis, they all meet at the center of gravity. We also have maximum gross weight. This is the maximum weight that an airplane can be in order to take off or to taxi, different things like that. And then there's this thing called zero fuel weight. This is the maximum weight of an aircraft without considering the weight of the fuel on board. Sometimes we use this so we can calculate how much baggage we're going to take, and then we pack on fuel and we figure out our range, like how far we're going to be able to fly. Zero fuel weight, sometimes called ZFW. BEW, the basic empty weight, is all the parts of the airplane plus the optional equipment, unusable fuel that can't be drained, and full operating fluids like oil. Useful load, that's the weight of the crew and the usable fuel. Takeoff weight, the aircraft's weight when it takes off. There's a maximum takeoff weight for every aircraft. For example, the Skyhawk, the Cessna Skyhawks, the one that I fly, the maximum takeoff weight is about 2,650 pounds. It can't weigh more than that, or it can't take off safely. All right, next up says the formula for figuring out what CG is. Just write down total moment divided by total weight equals CG, center of gravity. And we're going to talk about that formula and use it a lot in class. We'll do some performance problems. And then we're going to talk about load factor, because this is how much load we're putting on the airplane, how much force we're putting on the airplane. the ratio of the total load supported by an aircraft's wings to its total weight, affecting the stress on the airframe during maneuvers. We're going to talk about this chart a little bit and how load factor works. And then we're going to talk about there's two different types of charts. There's table charts and graph charts, and we're going to learn to use both in this class. Now, where would you find these charts in the real world? You would find them inside the airplane flying handbook, or the POH, sometimes we call it the Pilot's Operating Handbook. And usually in section 5, there's a whole section on performance with lots of different performance charts in there. Some are table method, and then same airplane, some are graph method. So you just kind of have to learn to read both of them. We'll also use some of the examples from the actual FAA written tests so you can get a sense for how they use their charts. Takeoff distance is one thing we're going to calculate. This is the distance required for an aircraft to accelerate from a standstill to a specified speed and lift off the ground. You can also figure out what the distance is to clear a 50-foot obstacle at the end of a runway. We're going to learn to use this chart. It looks intimidating now, but once you learn how to use it, it's really not too bad. Time to climb. How long is it going to take me to climb? Right? So let's say this is the time required for an aircraft to reach a specified altitude from a given altitude. Now you might say, okay, I'm going to fly to 6,000 feet and I climb at 500 feet a minute and 6,000 MSL, mean sea level, and I climb at 500 feet a minute. So therefore it's going to take me 12 minutes because 500 feet is 1 minute, 500 more feet, that's 1,000 feet. That's 2 minutes, 2 times 6 minutes, or 6,000, sorry, that's 12. So 12 minutes. However, we're not always going from sea level. What if we're climbing from 4,500 feet to 7,500 feet? Well, that's a difference of 3,000 feet, so we want to know the time to climb. We want to be able to use that chart. Pretty easy chart to use, actually. Endurance and range. We're going to learn the difference in endurance and range. Endurance is how long you can stay in the air. Range is how many miles you can go. There are different charts for that. But one thing we're going to talk about with both those charts is the fuel burn rate. This is the rate at which an aircraft consumes fuel, usually expressed in gallons or liters per hour. All the airplanes I fly here in the U.S., they usually say GPH, gallons per hour. So endurance is the maximum amount of time an aircraft can remain in flight with a given fuel quantity. We're going to learn that chart. Range is the maximum distance an aircraft can travel from its starting point to the destination with a given fuel quantity. So how many, can I fly 100 miles? Can I fly 500 miles? How far can I go? Looks like that. This is a rule I just teach in class. You really don't need this to pass your FAA written test. However, I like to teach it because it's just good flying practice, and it's called the 3-to-1 rule. So for every 3 nautical miles of horizontal distance you travel, the aircraft will lose about 1,000 feet. In other words, the descent rate is about 300 feet per nautical mile. So you're flying along, and you're at 10,000 feet, 10,500 feet, and the airport is at 6,500 feet, or the traffic pattern is. So I need to go from 10,000 down to 6,500 feet. So what I would do is say, okay, 10,500 minus 6,500, where I am, where I need to be vertically, that's 4,000 feet. I need to lose 4,000 feet. And I don't want to start too late because then I come screaming into the pattern too fast. Everything's all discombobulated. I don't want to do it too soon because maybe there's terrain out here, or I want to be efficient, right? So I got to lose 4,000 feet, 10,500 feet, and I need to get down to 6,500 feet. So you take the difference. 10,500 minus 6,500 is 4,000 feet, 4,000 feet. And then you say, okay, for every 1,000 feet, I'm going to move forward about 3 miles. So I'm going to lose 4,000 feet. So 3, 6, 9, 12. It's going to take me about 12 miles to descend down to that traffic pattern altitude. Is it perfect? Nah. You got to kind of fly a certain profile in the airplane to make it work all the time. But I fly the same profile just about every time. I go 1,800 RPMs in the Skyhawk. I put about 3 to 5 degrees nose down, and I just cruise on in there. And I use that 3-to-1 rule, and it works really well. You might be a little ahead. You might be a little behind, but you'll be way closer than just saying, I'm gonna wait till I see the airport and then descend. Well, okay. Well, what if it's night, or what if it's behind a mountain? You want to have tools like this to be able to do that. Especially if you're going to take our flight simulator lab class, you're going to want to know that rule. We're going to use it quite a bit. Then we have landing charts. We talked about climbing. We've talked about cruise flying, how far we can fly, how long we can fly, all that. But now we need to talk about landing. And this is the landing distance, the distance required for an aircraft to decelerate from approach speed to touchdown on the runway during landing. We're going to learn to use this chart. Or this chart. All right, crosswind component. So you may have heard of a crosswind, but the crosswind component is the component of the wind that acts perpendicular to the aircraft's direction of travel during takeoff and landing. There's a lot of big words in there, so we're going to talk about that. But as you're coming into land, if there's a direct crosswind, the plane's going to try to get pushed off the runway. So I'm trying to land on this runway, right? And, oh, sorry, my hands are backwards. And I'm keep getting pushed off that runway one way or the other. I want to be on the center line of that runway. Now, what if it's not a direct crosswind? What if it's kind of what we call a quartering headwind? What if it's like this? Does it still push me off? Sure it does. It pushes me off a little bit, but is a 10-knot crosswind equal to a 10-knot quartering headwind? No. So how much effect does it really have? That's what the crosswind component chart does. Very easy chart to use. You'll learn to use that one in class as well. Looks like that. And here's some estimates, kind of what I was talking about there. And they do have limits. We'll talk about those limits. For example, it says right here, crosswind maximum limit is 20 knots at 90 degrees. So there is a maximum that the plane can overcome. And then at that point, you may not be able to overcome it. You're kind of a test pilot at that point. Two things that we're going to learn to use in class. One is called the E6B flight computer. And this is a manual or electronic navigational tool used by pilots to perform various calculations. Looks like there's an electronic one, there's a round one. We're going to learn to use the old school one. I have these for you to use in class. So you'll be learning to use this thing, spinning it, making calculations. You should get pretty fast at it. It just takes practice. So we'll be practicing. We'll be using those in class. And then the plotter. This is what we use to measure distances and angles on maps. So if we have we're going to fly from here to there, we can lay down a plotter, figure out wind correction angles, figure out all kinds of things. So we'll be learning to use those in class as well. Hopefully you got all that vocabulary filled out. That'll help free up your brain power. So in class you can concentrate on using the charts and not all the vocabulary. It won't be the first time you've heard it.